it's just math.
All right, Unit 8A.2. So we're dealing with exponential functions. The function usually is defined by y equals b to the x power. Notice here that this is a exponent. Therefore, it is an exponential function. Okay, also remember that your base is b. We're going to talk about this, but there are two requirements for the base. It can't equal 1, and it has to be greater than 0. So meaning it can't be a negative number, okay? And it also can't be 1. So we're going to, oftentimes, in order to understand exponential functions, it's easiest to plug in numbers. These numbers are given to you. If you were actually making one yourself and they gave you a function, you can choose any numbers you want to. It's usually best, though, you need to have like a negative and positive that are the same, okay? So I usually always choose these numbers, 2, 1, 0, negative 1, negative 2. And sometimes it'll be different depending on fractions. So if we plug 2 into this equation, that means you have 3 to the second power, which equals what? 9. Okay. 3 to the first power is? 3. What is 3 to the 0 power? 1. Okay, so now when I get 3 to the negative 1 power, what happens?
I do 1/3.
Good, you end up bringing this to the denominator, and we end up with 1/3. Which means, what would negative 2 be?
1/2.
1/9 is correct. Do you guys notice a correlation between our negative and our positive number? They're basically flipped. Exactly.
Oh, I get it.
Okay? So now we're going to graph. I can't talk today. We're going to graph it. We're going to go right 2 up 9, which is exactly at the top of this graph. Over 1 up 1, 2, 3. Does everybody understand how to graph ordered pairs?
Mm-hmm.
I'm hoping you do. If you don't, please let me know, because you need to know how to graph ordered pairs. 0 up 1 is my next point. Then when you go negative 1 1/3, just make a mark, a little bit above the line. When you have negative 2 1/9, it's still just like a little bit above the line. You don't have to be exact. But basically, with exponential functions, it is never going to end up touching this line. Okay? Because there is no way that you can get an answer of 0 with an exponent like this. Right? Because if I plug in 0, what do I get?
0.
I get 1.
Oh, 1. Yeah.
And if I plug in negative numbers, I'm just going to end up getting what? Fractions. Okay? So this line goes like this, and the only thing that's going to happen is that it's going to get closer and closer to the x-axis. But it's never going to touch the x-axis, because it'll never be 0 for your y. There's no way to get an answer of 0.
So we gotta graph into the line.
Yep. Okay, so basically this is a graph when you have a whole number to a variable in your exponent. Okay, so now let's see what happens with the graph when you have a fraction to an exponent. Okay, so we're going to do the same thing with the numbers that we plug in. So if I have 1/5 to the second power, what do I get?
1/25.
Good. 1/25. Because we have to square everything inside there, right? What will I get when I plug 1/5 to the first power? What is 1/5 to the 0 power?
1.
Very good. What will happen with 1/5 to the negative first power?
5.
Very good. It becomes 5 because you have to flip it. What will be 1/5 to the negative second power? 25. Okay, so now let's go and graph this. So over 2 and up 1/25. So again, I'm just going a little bit above my x-axis. Okay. Next one, 1 1/5. Again, I'm going to go over 1, and then it's just up a little bit from the x-axis. 0, 1 is right there. Negative 1, 5. And then at negative 2, it's off the chart, so I'm not even going to graph it. So when I put in negative values, it's going to, what's going to happen with the y? Get bigger whole numbers,
yeah.
right? When I put in just regular positive numbers, I end up getting smaller fractions.
Right.
Will this ever hit the x-axis?
No.
No, there's no way I can ever get 0. Okay, so this one goes this direction. So when you're dealing with exponential functions, if you have a whole number here, your graph is like facing left. If you have a fraction here, your graph is basically facing to the right. Okay? All right. Questions before we move on? All right. So exponential function graphs look like this. And we just did them. Okay, so you're going to have one that goes this direction or one that goes this direction.
They'll never
Okay.
be below, right?
Yeah, neither one of them will go below the x-axis. Okay? Graphs are called decreasing if they drop as they go from left to right. So you always think about reading a book, and you read a book from left to right. You read graphs from left to right as well. So notice how this is dropping, therefore this is a decreasing graph. Graphs are called increasing if they rise as they go from left to right. So again, if you look at this one, it's rising, therefore that's an increasing graph. And then it tells you on increasing or growth graphs, the larger the x value, the farther from the x-axis the graph gets. The smaller the x value, the graph gets closer to the x-axis. So, on example 3, if the equation of y equals 5 to the x power is graphed, which of the following values of x would produce a point closest to the x-axis? Okay. I put a graph here if you want to graph it. So you could make a t-chart and plug in the values how we did. Okay? But I want you to go back and look at what we just did. So they're asking for a value that is closest to the x-axis. So if you're looking at this y equals 3 to the x, because that's going to be a similar graph, which values are getting closest to the x-axis?
9?
The 1, 9.
Yeah.
So it's going to get even closer the larger the negative number is. Okay? So basically, the smallest the number is, dealing with like negatives and stuff, the closer it will be to the x-axis. So looking at this, on number 3, without even doing anything, what do you think your answer is going to be?
B.
B is correct. Okay, so by showing me on your hands or your whiteboards, I want you to try to do number 4 on your own.
No? Yeah. String just get
Remember that the graph for a fraction is different than the graph for the whole number. Okay, and if you need to, you can plug in points, but this graph is different than our other graph. What? This graph is actually a graph that looks like this. Okay? And this line will get closer and closer to the x-axis the smaller it gets. This graph goes the opposite direction, you guys. It goes this direction. Okay? And as this line moves, this line, so the larger the number, the closer it's going to get to the x-axis. Okay? The larger the number, the closer it'll get to the x-axis. Where on number 3, the smaller the number, the closer it would get to the x-axis. And it has to do with how these are different. Okay? So therefore, so with your fingers, I want you to tell me A, B, C, or D, 1, 2, 3, 4. Tell me what your answer is. It's okay if you're wrong. Okay. Well, I'm glad that some of you are putting 3 and 4. The correct answer is 4, D. The reason is D is larger. Okay? D is 1 3/4, where C is just 2/3. The larger the number, the closer it gets to the x-axis. If you wanted to, you could plug each of these values in to this equation and see which one's closest. So if you are not sure, plug in each of these values and see which one is closest to the x-axis.
Wait, so is D because D is long or the other?
It's the largest number there. So the larger the number, the closer it is to the x-axis.
That applies to fractions, like, because you said the negative number, like.
So on this one, it was the smallest number, and the smallest number out of all of these is -1. Okay, on this one, it's the largest, and the largest out of all of these is the 7/4. Okay. So now remember at the beginning I told you how we couldn't use certain points? The values for our exponent had to be not equal to 1 and greater than 0, meaning not negative. So we're just going to look at this. So our base here cannot be, it's supposed to not be 0. Okay? If you put 0 here and you raise it to the second power, what do you get? 0. What am I going to get for all these values?
0.
Okay. It does not make anything. It's a flat line. Okay? That, you know, 2, 0, 1, 0, all this stuff. Okay. So this is why you cannot have 0. It's not going to give you any kind of function. Okay? So, the base must never be 0, 1, or negative. Same thing if you did 1. Okay? So if I were to do 1 to the x power and I plug in values, what's 1 to the second power? 1. What's 1 to the third? 1. What's 1 to the -1? 1. So again, see how it would make another flat line? So this is why you also cannot have 1. Okay. Anybody know why you could never have a negative base? So for instance, if I had -2 to the x power, what is, and we'll just do a little t-chart here, okay? -2 to the second power is what? +4. Okay? What is -2 to the first power?
2.
-2.
-2, yeah.
-2 to the 0 power is 1. Okay? -2 to the negative first power would end up being -1/2. And then -2 to the -2 power would be a +1/4. If you were to go and graph these, I'm just going to use a different color here. If I go over 2, up 4, and then I have 1, -2, and then I have 0, 1, is this making any kind of line? No. So that is why you cannot have negatives. Because when you square a negative, you get a positive, but when you have an odd negative, you get a negative. So when you have negatives and positives, it doesn't make a graph. Okay. All right. Number 6. Oh, no.
I was about to say it.